Hi again, my name is José Pedro Borrego, and now I will present the practical aspects of our field trial or of our pilot to study the LSA concept. I will share with you my presentation. Okay, I hope you are seeing the first slide. Um, and you can see the logos of our partners. We have First Spectrum, Huawei, Nokia, Mel, Vodafone, NOS, RTP, SIC, TVI, and IT. The first part of my presentation is, of course, the framework and objectives of the Portuguese study on LSA. The main drivers to promote this study in the beginning were to get fundamental know-how and experience in advance to prepare or not. At that time, we didn't know if the LSA concept was suitable to be applied in the Portuguese context. And we would like to know more about this LSA concept to study the introduction of a new paradigm of spectrum sharing, of a solution which was not yet commercially introduced. So the other driver was the necessity of defining specific conditions and restrictions to be applied to the Portuguese reality. Some particular technological issues have not been tested in other European LSA pilots that we considered very important because in Portugal we have a very specific situation in the 2.3 gigahertz bands. That is, the spectrum is allocated to TV operators for PMSE purposes, and the usage of this spectrum is not linear nor very predictable. So we identified some aspects that, in our opinion, should be thoroughly investigated and developed from scratch. That is why we developed a prototype of a hardware device to detect the spectrum activity in order to optimize the spectrum utilization. And the last driver that we considered to promote this study was that the European Commission has shown a strong interest in following the progress and taking note on the results of projects in this field to be carried out in other member states. These were the main reasons that we had to consider the development of this study. Well, the question that we have now is why the Portuguese pilot is so unique. Uh, Maybe you are wondering what are the differences between our pilot and the other ones that were tested in other European countries. So the first differentiate factor is in fact the automatic interaction between the incumbent user and the LSA database using a dedicated hardware device that we named LSA Warner, which operates in a transparent way. The second factor is the introduction of enhanced redundant mechanisms to protect the incumbent user by adopting automatic spectrum sensing techniques, and also the optimization of exclusion areas and the sharing or utilization time of this band, the 2.3 gigahertz band, using dedicated hardware, the LSA Warner, developed during the course of this project. So, with these mechanisms, we aimed at reinforce the protection against interference, not only based on estimations or theoretical calculations produced by computational tools or simulators, but also based on the feedback gathered from the sensing devices. So we use the Warner to monitor the activity and to measure the spectrum in the field in real time. The last factor is, in fact, the development of a technological solution that is minimally intrusive and adapted to the national reality in order to minimize the impact of the introduction of the LSA model in Portugal, taking into account the type of utilization of the 2.3 gigahertz band that I will explain later on. I would like to stress some strategic aspects behind this project. And the first one is the involvement of industry partners, mainly manufacturers, TV broadcasters, communication service providers, namely the mobile network operators, and all these partners enable important synergies to design real scenarios to be tested and an appropriate integration and interoperability of technologies, solutions, and devices. The other aspect that I would like to stress here is the contribution to the qualification of the Portuguese industry, broadcasters, mobile operators, R&D units, and the regulator with knowledge and critical capacity to propose alternative solutions of spectrum sharing and at the same time to be updated on the trends and state of the art in this area. And the last strategic aspect is the validation of a technological solution which was developed here in Portugal under real assumptions and test scenarios suitable for international demonstration. Here we have our partners. We have a group, the mobile network operators, and we have Mel Altice, the first one, NOS, and Vodafone. And the TV broadcasters, RTP, SIC, TVI, the regulator, ANACOM, of course, that is the promoter of this project. From the industry side, we have Fair Spectrum, Huawei, and Nokia. The R&D unit is the Institute of Telecommunications. It is important to note that in Portugal, the 2.3 to 2.4 gigahertz band is used by incumbent services, SAP, SAB. The band is divided in three main slices, each one with 30 megahertz of bandwidth. The first slice is assigned to RTP. The second one, the second 30 megahertz channel is allocated to TVI, and the last one to SIC. Well, typically, these incumbent users are PMSEs. Here, we don't know where the TV operator is using the spectrum because this kind of PMSE applications are mainly for news gathering, using video links, and we don't know where the operator is reporting a given event or given situation. We don't know because it's very dependent on the agenda, the mediatic agenda of the country. This specific spectrum in the 2.3 to 2.4 gigahertz band, they can use the spectrum anytime, anywhere within the country, and we are considering the Portugal mainland and also the islands, Azores and Madeira. So we don't know when they are using the spectrum, nor where they are using the spectrum, they don't need any previous communication or additional requests before using the spectrum. So the users, the incumbent users, they don't need to ask ANACOM to use the spectrum. Um, as you may understand, and you are concluding with this, is that there are some underused spectrum. And the LSA model is a good tool, a good instrument to cope with this issue that results, that arises from this particular situation in Portugal. So the next question is how to optimize this spectrum utilization, and to optimize it without compromising the incumbent services. It would be very interesting and useful to identify uh, specifically where and when incumbent services are being used. Better if this could be done automatically and transparently to the user. That is why we proposed a new device, the LSA Warner, to the basic model of LSA. So we are introducing here a new concept that is based on somehow the concept of white space, because we need to add to our device the spectrum sensing and detection capabilities, the geolocation, and we need to assure the connection between the Warner and the LSA controller. So that's why we are proposing here this part of the system that is very innovative, and we tested it very successfully in the field, and we would like to present the concept to you. I'm sure that Nuno Borges Carvalho from Institute of Telecommunication will explain this deeply. For now, we need to know that the Warner has these capacities. After presenting the LSA Warner and the main features of the device, it is important to give you a brief overview of the conceptual network diagram that we considered when we designed the pilot for the test. So this is obviously conceptual network. The final network that we implemented is a simplification of this that you are seeing in these slides. You can see two different mobile network operators here, and the respective LSA controllers, the connections between the controllers and the database, the LSA repository, and the interactions with the NRA and the interface between the incumbent users. This concept was not implemented in our pilot, and the maybe the most important part here that we are adding to the LSA basic model is the Warner, the LSA Warner. The Warner has a geolocation module that uses the GPS protocol in order to acquire the GPS position, and this is very useful when the coordinates are transmitted to the controller. The controller knows what are the base stations to shut down in order to give the spectrum to the PMSC incumbent user to the normal activity, mainly video links, the connections between the cameras and the SNG units, or the outside broadcasting units, and of course after the utilization of the spectrum by the PMSE incumbent, the LSA warner is turned off, and the controllers is informed that the mobile network can again use the spectrum. So this is the main network diagram, and with this picture, maybe now you are more familiar with our pilots. To design the tests, the plan of tests to the field trial, we would like to build a test bed environment capable of reproducing under realistic conditions the operation of LSA network in this band, 2.3 to 2.4 gigahertz band, according to this national reality, that is the use of video links with the uncertainty where and when the video links are using the spectrum. So we define some performance tests using these PMSE video links and the LTE TDD mobile networks. Operating according to the LSA concept and to the performance tests, we took into account the interference analysis that we evaluated in the field with measurements, the quality of service evaluation, both for incumbent, the video links and the mobile LTE TDD technologies. The idea was to identify the ideal conditions to both operators use the spectrum. So we evaluate the signal to noise ratio degradation. We also evaluated we measured the evacuation and recovery time, that is the time to react to a given request from an incumbent. We also characterized the indoor and outdoor coverage provided by the mobile network. These tests, we can find them in our final report. The report includes the main conclusions and recommendations for the implementation of the LSA solution here in Portugal. So this is the link that you can use to get the report, the final report. The final report is very comprehensive and detailed, describing all the tests, the results, the conditions, the spectrum measurements that we carried out in the field. If you would like to know more about our LSA pilot and our LSA study, please visit our website and download the report. Now I'm going to focus my presentation on the field trials. This is the pilot network that we actually implemented to study the LSA concept in Portugal. You can see one network, in fact, is Node B base station that is controlled by the LSA controller that was implemented by Fair Spectrum, connected to the repository, and the controller manages the interactions between the Warner and the network and the mobile network. Here you can see the PMSC incumbent video links. We tested two sets of VisLink systems, and we also had a Node B, a base station in a standalone mode, because the operator was not able to overcome some security issues and we use this standalone Inode B only to study the interference. The full operational Inode B was used to test the entire concept. This is the main diagram, and this is the network that was actually implemented for test purposes. These pictures give you an idea of the hardware devices that we developed with the Institute of Telecommunications. The power detector, that is the hardware front end of the Warner to sense the spectrum and to evaluate the power levels that the Warner receives. The final prototype is in the middle. You can see all the hardware that IT developed for us, and the detail of the GPS and communications module on the right side of the slide. This is the test unit that we used for the pilot implementation here in the lab to measure the parameters, the technical parameters, and to set the algorithm and the protocol to communicate with the Fair Spectrum controller. This is the diagram of the core network that we use to test the full network. And NOS provided us with the conditions to connect our LSA Warner to the core network, and with a connection to the controller, to the LSA controller. So this is basically what we implemented in practice. This is the standalone Inode B. This is Huawei technology. Was implemented in the MEO base station at University of Aveiro. And this is the rack, the hardware rack inside the site. This is the Nokia Inode B. We use this compact unit, that is the Nokia Flexi Zone Micro Small Cell. We installed in a small mast that you can see in the picture that we have on the left side of at the bottom of this slide, and some measurements, some spectral analysis that we performed during the tests. This is the video link, the video link system we used, a VisLink unit. In fact, we used two units like this. You have the transmitter that is attached to the camera and sends the signal, the wireless signal, to the array of receiving antennas. You can see four antennas that are used to provide some diversity, and this is what we used during the tests. You can see more details about the setup that was used. And this is the testing plan. We defined some zones, some of them with line of sight, other ones obstructed by buildings, building blocks. We defined the zones, the distances between the mobile network Inode B and the PMSC incumbent system. We define some spectral configurations, spectral arrangements in order to study the overlapping of just one channel, two channels, and all the combinations that you see in this slide were tested in our pilots. This is a table with the detailed tests. The first test is the overall functioning of the LSA control system. The other tests are tests of compatibility between the PMSC and the LTE signals. And the last ones are the tests indoor and outdoor in order to understand the performance degradation in under different scenarios. This is an example of spectral measurement. This is the overlapping of LTE signal over the PMSC. So you can see the spectrogram and persistence spectrum. This is the project team, and now we will watch a video and you can see the details of the tests in the field. I will come back after the video to wrap up the results, the project, and to present some conclusions. I'm almost concluding my presentation, and now I'd like to show you some of the main results that we got from this pilot. And the first one is that the system showed stable communication between the Warner and the LSA controller or repository. Um, the Warner successfully detected the existence of the LTE signal transmitted by the NOS in node B, even with the overlapping uh, of digital video signal of the PMSC system. The LSA controller was also successful in deactivating the LTE signal transmitted by the node B so that the PMSC system could use the same shared spectrum. These times are very important. The detection and actuation time was about 50 seconds, the evacuation time, and the reestablishment time was also about 50 seconds, the recovery time. So these are the main results that we got from our pilots, and I would like to give you some of the fundamental conclusions that we drawn from our study. And the main conclusion is that the LSA concept was proven, and the LSA Warner functioned successfully, allowing the deployment of basic features that can enable the introduction of the LSA model tailored to the scenario of spectrum use in the 2.3 to 2.4 gigahertz band in Portugal. The LSA Warner detected LTE TDD signals and activated control mechanisms, responding as desired to the LTE Node B. From a technology standpoint, and based on the pilot tests conducted in Portugal, we were able to validate the LSA concept and enable sharing of the spectrum in the 2.3 to 2.4 gigahertz band without further constraints on the conditions considered. These results are highly relevant to the future of spectrum management, opening the door to other studies of similar importance to supplement this one, not only to refine certain technical aspects that can be improved, duly identified, but also to shape a legal and regulatory framework to lay the groundwork for the introduction of the LSA model. Thank you very much for your attention. We will continue presenting the Portuguese pilot, the Portuguese LSA pilot now with our partners. Will present their own visions on the project, on the so let's move to the next panel, and thank you very much for your attention. Thank you very much.